Okay, this is for section 4. Moving on to logarithms. Um, as you can tell by the number of problems here, it's a little bit longer of a section, but only because it's going to tie in a lot to what we did with exponential functions and making the transition back and forth. So a lot of the questions, a lot of the problems you're going to be asked to work are very simple questions where all you're going to do is transform from one form to another. Okay. So first of all, again, let's look at what we've talked about here. We talked about exponential functions, and basically an exponential form in its basic form looks like this. You have some base. That base is raised to an exponent, and then as a result of those numbers, you get some answer. Okay, so that's it. Those three values. Now, logarithmic functions are, you see the word log in these questions here, but logarithmic functions are inverses of exponential. So we found out in section 2 how to take a function and form its inverse. What we want to do here is talk about how do I take an exponential function and create its logarithmic inverse. Okay, well, it can be done very simply by just transposing these three things. Okay, so what we want to do is we want to first of all introduce the word log. The base here becomes a little base as a subscript. The answer is moved over to this side. And then the exponent moves over here by itself. Okay, so that's all it takes. So jumping from one form to another creates no new information, doesn't require any new information. All we do is either include or exclude the word log and then move those other values around. So for example, let's take a problem we know to be true. Okay, if I know 5 squared equals 25. Okay, that is an equation in exponential form. Okay, now what I can do is I can write its inverse form, logarithmic, by taking log base 5 of 25 equals 2. And that's it. That's it. That's all there is to do. Okay. Now, there are some other interesting properties that we're going to talk about as we go along, but the first part of this is all it's going to require is take an exponential form and change it to logarithmic and vice versa. Okay. So let's look at those and then we'll come back to some of these notes here. So on questions 1 through 5, it says change each exponential expression to an equivalent expression including logarithm. So number 3, okay, 2 to the x power equals 7.2. Now, 2 is your base, x is your exponent, and then my answer is 7.2. So based on this, I can say log base 2 of 7.2 equals x. And you're done. Okay. Now, there are a couple special forms. We have 2 special forms that will also play a role, and I'll talk about them in general first and then show you an exercise or two. Okay, now we talked about the natural base. Okay, E is the natural base. Now, when you take that base and take its log, that would be log base E, but that also has a special term. It's called the natural log, and it's abbreviated ln. And ln is on your calculator. We'll be using that here in a little bit. But the natural log, ln, is a way of taking the natural log base e of a specific number if we're asked to evaluate. Okay, another special one that we talked about. So this is natural log. Okay, we also have, since our number system is a base 10, they also created a log this way. Base 10 becomes log base 10, which we use as just the word log. If you don't see a number as a base, it's automatically assumed to be this, log base 10. This is called a common log, a common logarithm, okay? And that is also on your calculator, okay? All of the other bases that we might create, for example, up here where we have log base 5, you can't do that by itself on a calculator. There is a formula that we can use to adjust and adapt, modify to use it, but the calculator will only do log base E and log base 10, natural log and common log. Okay, now if they give you one form, we can change it back. So if they give you log base E, okay, or give you natural log, we can write that as log base E, okay, and we will, okay. If you have log without a number, it's log base 10. You can fill the 10 back in, okay. So on this example number 5 is the one I want to look at here. On question number 5, e to the x equals 8. We could write that problem as log base e of 8 equals x. And log base e, just what we said, you can rewrite it, symbolize it, ln of 8 equals x. Okay? Try to use the best form available, okay, in each one of these exercises. But again, they give you the exponential form. I'm asking you to change it to a logarithmic form. Okay? On 6 through 10, it's given in logarithmic form. You're changing it back. Okay? Look at number 8. Log base 3 of the number 2 equals x. So again, take out the log. Taking out the log, this will be 3 to the x power equals 2. Okay? So it'll look something like that. Okay, 3 to the x power equals 2. Again, no log anymore. Exponential form. Okay? On number 10, this one, because it's given as a natural log, I want to rewrite this, putting the log back in. So this will be, first thing I'm going to do is I'm going to write this as log base e of x equals 4. And then, again, get rid of the log. The base e comes up. The 4 becomes your exponent. The x becomes your answer. Okay? Now, on 11 through 18, how do I use that to actually solve? Well, in each one of these, they want you to find the exact value of each logarithmic expression there without using a calculator. This kind of goes back a little bit to what we were doing in section 3 with a little bit of modification here, okay? We can find out what those are, okay? So, for example, number 12, okay? Number 12, I know that log base 5 of 25. What I want you to do, first step, is I want you to put an equals x at the end of that equation. Now what I want you to do is rewrite the equation in exponential form. That's the general rule for solving a logarithmic, is change it back to exponential form. Okay, so this becomes 5 to the x power equals 25. Well, the other thing we got done talking about is if I can make both sides of that equation have the same base, then that means the exponents have to be equal. Well, I know that 25 can be written as 5 squared. So 5 to the x equals 5 to the second So the 5's are equal, so I know that x equals 2. Okay? Now, again, when you see fractions like you do on 13, I want you to think negative exponents. Number 14, it says log of base 1/2 equals 16. Again, put in the equals x. Okay? I'm going to write that as 1/2 to the x power equals 16. Okay? So the number 1/2 can be written as 2 to the negative 1 power to the x power. There's your 1/2. And the number 16 can be written as 2, same base, to the 4th power. So if I multiply these two together, the negative 1 and the x, I get negative x equals 4. So the bases are the same, so I can set the exponents equal, and that means that x has to equal negative 4. Okay? When you see radicals, like you do on 16 and 17, okay, remember we know how to express radicals using fractional exponents. So on number 16, set it equal to x, and I'm going to write this as 5 to the x power equals the cube root of 25. And that means that 5 to the x power equals 25 to the 1/3 power. Change them to have a common base. 5 to the x equals 5 to the 2nd to the 1/3 power. There's the 25 rewritten as 5 squared. And so 5 to the x equals 5 to the 2/3 power when you multiply the 2 and the 1/3. So x equals 2/3. Okay. On number 18, remember ln stands for log base e of e to the 3rd equals x. So e to the x equals e to the 3rd. And you move things around. So again, x equals 3. Okay. 19 through 20. Okay, type those into your calculator. It says round to 3 decimal places. On these problems on 20 and 21, here's your little hint. Okay, put parentheses when you type in. Put parentheses around the numerator and denominator on both 20 and 21. Otherwise, it will not do the order of operations correctly and you'll be off. Okay, so be careful about those. Okay. Some more of the same on the next page, 22 through 30. Again, you're solving. They're a little bit higher level, but again, some of them are exponential. Okay, some of them are logarithmic. If they're logarithmic, rewrite them as an exponential form. Okay, so look at number 24. If I have log base x of 4 equals 2, that means that in exponential form, x squared equals 4. Okay, so that's going to be true if you square root both sides, x equals plus or minus 2. Okay. 25. Again, change it, rewrite it. So I have log base e of e to the negative 2x power equals 8. If I rewrite this problem, I get e to the 8th power equals e to the negative 2x power. The bases are equal, so I can set the exponents equal. Negative 2x equals 8, so x equals negative 4. 28. 27 and 28 both have base E. So what I'm going to do, this is actually going to have to bring in the other rule. So if I want to get rid, because this is already an exponential form, okay, and I have no way of undoing an E that's only on one side, okay, so what you want to do, okay, if you have a natural base, okay, the only thing that will get rid of a natural base is a natural log. So I'm going to take the natural log of both sides of this equation. Oh, excuse me. Okay, now what that does for me is that allows me to cancel out the ln and the e on the left side of the equation. Okay, so ln and e cancel out. You're left with 2x plus 8 equals the natural log of 8. I want to subtract the 5 over. So 2x here, ln of 8. I'm going to do something. I'm going to make that negative 5 out in front. Negative 5 plus. Okay, because I don't want you to subtract the 5 from the 8 and get 3. Okay, you can't do that because the ln is attached to the 8 and only the 8. Okay, if it is attached to both of them, you can put them together. But in this case, and so then all I want to do to finish this is divide both sides by 2. So I can say here that x equals negative 5 plus the natural log of 8 all over 2. And that will be, you'll see some more problems like this in section 6 as well. In this section, there's only these two. The rest of them should work out a little bit better. Okay, but again, create the common base. Okay, change it back to exponential form. Create a common base and then set the exponents equal. Okay, so that gives you a little bit of a format to go by. I'm gonna do just one more here. Look at number 30. It still is the same. But again, first step would be to rewrite this problem. So this would be 2 to the negative 3rd power equals 8 to the x power. Okay. Now, I need to create a common base, so I'm going to use 2. 2 to the negative 3rd equals 2 to the 3rd to the x. The bases are the same, so the exponents are equal. Okay. So negative 3 equals 3x. Divide by 3. So x equals negative 1. Okay. And again, find the problems on the test. Find the problems on the test that are like these. Okay. And complete those. And email me with any problems, anything different that I haven't maybe done explained well enough to you. Okay, I can give you some more solutions. Okay, but that should help you a little bit finishing up both this section and the section on the test. Okay.